So today's session, then, we're going to look at the neuroendocrine system, and we're also going to look at it in relation to exercise, similar to what we've been doing with regards to the cardiorespiratory system and the muscular system. So first of all, just a quick recap. We're going to look at some level 2 stuff. So the nervous system, first of all, is split into 2 divisions. So we've got the CNS, the central nervous system, and the PNS, the peripheral nervous system. Can anybody tell me what makes up the central nervous system?
Brain and
the spinal cord makes up the central nervous system. So this is your command center, if you like. So receives all the information, interprets the information, and sends out the action to be to happen. The peripheral nervous system is then everywhere else. So 33 branches off of the spinal cord out to the rest of the body. Now, the peripheral nervous system is split into 2 sections, first of all. Can anybody tell me what they are?
Sensory.
Not sensory. It does. One of them does begin with S. Anybody?
I thought it was sensory and motor neurons.
No. So the peripheral nervous system splits into somatic and autonomic. Okay. So somatic is all about the voluntary side of things. We can control it. The autonomic, as it kind of says, happens automatically. We don't have control over it. It's the involuntary side. So if we think about somatic, when it comes to skeletal muscle, for example, which is voluntary muscle, we decide to contract it and relax it. When we look at autonomic, we think about maybe more internal stuff that happens. So things like the digestive system, hormones being released, which is what we're going to look at in a little bit more detail in a second. Hormones being released internally, artery walls, so pumping blood around the body, circulatory system. Okay, so all of that happens automatically. We cannot control it. So to give you some examples, we think about exercise. So during exercise, we are the ones who decide to go for a run. So we decide to put one foot in front of the other and keep running and keep moving. We can stop when we want to. We can start up again when we want to. So that is somatic. We decide to run. Now, because we have run, it means that we then need to supply those working muscles with the energy, oxygen, and all the nutrients required to keep running. So the autonomic system kicks in. So heart rate will increase to pump blood to those working muscles. So we need a bigger supply of oxygen, nutrients, energy, etc. So the heart rate will increase. Stroke volume will also increase. So the amount of blood pumped per minute. So the heart is actually going to pump harder and stronger. Okay. Breathing rate will increase because we need more oxygen in to fuel the system. So breathing rate will increase, which happens automatically. We can't control it. Blood pressure will increase. So the pressure on the artery walls also increases. Body temperature increases. So the working muscles, because they are working now, they're warming up the body. Our whole body temperature will increase. So sweat glands will open to try and cool us back down again. So we see even though we've just decided to go for a run, all of these internal things happen automatically to fuel us and to keep us going for that, for the duration of our activity. Okay, so we've got the somatic, we decide what happens, and the autonomic, it happens automatically. So the autonomic is also split into 2 sections. Can anybody tell me what they are?
sympathetic and parasympathetic.
Yeah, very good. Cool. So we've got sympathetic, war, high intensity, parasympathetic, peace, low intensity. So to give you an example again, we think about our exercise. So we decide to go for a run. So leave our house and we start to run. So the first 5 minutes, we think about our warm up. Okay, what tends to happen to heart rate, blood pressure, breathing rate, temperature during a warm up?
All starts to increase, yeah.
Yeah, so they all increase. Okay, so all of that increases. So we think war. We've put stress on the body, so intensity goes up, so heart rate goes up, breathing rate goes up, blood pressure goes up, temperature goes up, etc., etc. Then we're into our main session. Okay, so during the main session, and not just thinking about a run now, but think about an actual workout where everything goes up even further. So our RPE scale, we're now jumping from 5 on the RPE scale up to 7, 8, possibly 9, things like that. So now stress level goes up even higher. So heart rate goes up higher, breathing rate goes up higher, temperature goes up higher, blood pressure goes up higher, etc., etc. Everything goes up. So it's all in the sympathetic side of the autonomic peripheral nervous system has kicked in. Stress level is up here. So then we finish our main workout and we decide, okay, we now need to do our cool down. So what we're doing now is we maybe jump on a piece of cardiovascular equipment, start at a higher intensity, and then gradually bring our intensity down during the 5 minutes or whatever we're doing for our cool down. So what's happening now is the parasympathetic side is kicking in, bringing our heart rate back down again, bringing our blood pressure back down again, bringing our temperature back down again, etc. So war and peace, sympathetic and parasympathetic, are always against each other, always trying to bring us back to what's called homeostasis, okay? Normal operating procedure. So if you think about it, during your main session, you maybe are doing an interval workout, for example. So in your interval workout, you're doing 1 minute of high intense work and you're doing 1 minute of recovery, easy pace jog, we'll say. So in that 1 minute of high intensity, sympathetic is kicked in, everything has gone up. During that 1 minute of recovery, parasympathetic is kicking in, trying to bring everything back down to its normal operating procedure. So you'll notice if you're working with a client that you're working hard, heart rate shoots up. Then we can keep an eye on their heart rate as we work in the recovery phase, and that heart rate is trying to come back down again. So the quicker a person can recover, the fitter they generally are. Okay? So parasympathetic and sympathetic are always working against each other. So that's an example of exercise. We can also think about when you eat some food, for example. So you have a normal sugar level in the body. Okay, so insulin and glucagon are constantly working to keep a normal sugar level within the blood. So when you eat, let's say, for example, you take a drink of Red Bull, which is high in sugar, sympathetic kicks in, so your blood sugar level goes up. So then the body will respond, sends a message to pancreas to release insulin to bring that sugar level back down again. Okay, so the parasympathetic is kicking in to bring the sugar level back down again. However, you drink more, and then the sugar level goes up, so the sympathetic kicks in again, bringing sugar level back up again. Okay, so parasympathetic and sympathetic are constantly working against each other to bring you back to homeostasis, normal operating procedures. So the function of the whole of the nervous system is to maintain homeostasis, okay, to keep the body ticking over without undue stress, without injuries, without illnesses. Okay, so if you get ill, the immune system kicks in to fight that illness, okay, and bring you back to homeostasis. Does everybody understand what I'm talking about with that?
Yeah.
Cool. Okay. So the endocrine system then, primary role is to control and maintain homeostasis. The endocrine system utilizes a chemical messenger system releasing hormones from a series of glands located around the body. So the gland will release the hormone into the bloodstream. The circulatory system will transport that hormone around the body to the organs or tissues that are affected. Okay, so for example, we've just gone back to our insulin. So we take sugar into the body. So the pancreas, which is the gland, the pancreas is stimulated to release the hormone insulin into the bloodstream, and then the organ tissue, so the sugar within the bloodstream, will be reduced. Okay, so this happens with a variety of different things around the body, which we're going to look at in a little bit more detail in a second. So hormones are the chemicals released into the bloodstream to help control and manage the internal environment of the body. The endocrine system is the technical name given to our hormonal controls. And the function of the endocrine system then, so the endocrine gland will receive a stimulus. The gland will release the chemical hormone. The hormone travels in the bloodstream. The hormone is received by the target cell receptors, and the cell is stimulated to cause a desired response. It will then send feedback back to the originating gland. So sugar level goes up, we take a drink of Red Bull, the endocrine gland, pancreas, receives that stimulus. So the central nervous system sends a message to the pancreas saying, we've got too much sugar in our system. The gland So the gland releases the chemical hormone. So the pancreas will release insulin. Insulin will travel in the bloodstream. It's received by those sugar cells. This sugar cell is stimulated to cause a desired response. So it will break down that sugar and reduce the sugar level in the bloodstream. And then it will feed back to the pancreas saying, okay, we've brought our sugar level back down to homeostasis, to our normal level. So you can switch off the release of insulin. Does that make sense?
Yeah.
Cool. So this happens within loads of different systems of the body. So another example is if your body temperature goes up. So during exercise, body temperature goes up. So stimulus, endocrine gland receives a stimulus. So the sweat glands receive a stimulus. Message from the central nervous system says body temperature has gone up too high. Message to the sweat glands, you need to cool the system down. So release sweat out of the skin to cool the body. So the gland releases the chemical hormone, which will be sweat. The hormone would travel in the bloodstream, but obviously with this, we're basically targeting the cell receptors, as in we're trying to cool the whole body down. Then once our body temperature has come back down again, the response is sent back, and message is sent back to the central nervous system saying that we've come back down to a normal temperature. We can switch off the sweat glands so we don't have to sweat anymore because our body is back down to its normal temperature. Okay. So the different endocrine glands that we've got. So there are numerous glands that comprise the endocrine system, including the pineal gland, pituitary gland, thyroid gland, thymus, adrenal gland, pancreas, ovary, and testes. So what I've done is I've got slides on each one of these. I've also got a little handout that I'm going to send you, which has kind of got all of this information in a simpler format in a little table. So it will have the growth hormone, it will have its function, and it will have its source. So anabolic hormone, so the growth hormone is an anabolic hormone responsible for primary growth and development up until puberty. So it's produced by the pituitary gland and regulated by the nearby hypothalamus. So you can see those labeled on the diagram. The pituitary gland will release growth hormone. The hypothalamus will decide how much to be released. Its functions include development of bone, muscle tissue and protein synthesis, increases fat burning, and strengthens the immune system. So by looking at those functions, we can see why growth hormone is used as a performance enhancing drug, because the development of bone, muscle tissue and protein synthesis, so it'll break down protein better and make sure that protein is utilized more effectively. It will help with fat burning and it will strengthen the immune system. The thyroid hormones. So release of thyroid hormones is regulated by the pituitary gland. So the pituitary gland in the brain will decide how much thyroxine is released into the body. Its functions are primarily relate to metabolism, including basal metabolic rate, protein synthesis again, sensitivity to adrenaline, heart rate, breathing rate, and body temperature. So you may have heard of people who've got maybe an overactive or underactive thyroid. And what happens there is that they would find it difficult to either increase body weight or decrease body weight. Okay, so their basal metabolic rate is affected by the amount of thyroxine that is released into the system. So whilst it is rare, low thyroid function can lead to low metabolism, fatigue, depression, sensitivity to cold, and weight gain. If you've got an underactive thyroid, these are some of the things that can occur. Corticosteroids. So class of hormones that are released by the adrenal glands. So note where the adrenal glands are located. So the adrenal glands are located on top of the kidneys. Cortisol is released under times of stress to stimulate processes that protect the body. So primary functions include maintenance of energy by breaking down carbohydrates, fats, and proteins, reduction of inflammatory responses. So think about during exercise, if you're doing quite a high intense exercise routine, cortisol will be released to maintain the energy, so maintenance of energy. It'll break down carbohydrates, fats, and proteins, but it'll also reduce inflammation in different areas of the body. Aldosterone will control fluids and electrolyte regulation through the kidneys. So again, you think about if you're doing a long distance run, you may be taking extra electrolytes on. So the aldosterone will help to control that and regulate the amount of electrolytes that are released into the bloodstream. Catecholamines, okay? The most abundant are adrenaline and noradrenaline, which are released from the adrenal glands. So adrenaline is released during activity or exercise and when under stress. Its primary functions include, so increases heart rate and stroke volume, elevates blood glucose levels, redistributes blood to working tissues, and opens up the airways. So noradrenaline is a precursor to adrenaline. So noradrenaline is released, kind of does a little bit of an assessment and says, yeah, adrenaline, come on, you're coming with me. We need to increase heart rate, stroke volume, blood glucose levels, get blood to the working muscles that needs it, and also will help to open up the airways. So we think about during exercise, all of this needs to happen to help us to perform efficiently. Pancreatic hormones. So the pancreas releases two hormones in response to variations in blood glucose levels. So insulin is released after food intake, absorption, and a subsequent rise in blood glucose, blood sugar levels. When blood sugar levels rise, insulin is released. Glucagon is released when either when food has not been eaten for a period or activity has metabolized blood glucose stores, causing levels to fall below a certain threshold. So if your blood sugar level goes too low, glucagon will be released to bring sugar levels up. So insulin, glucose enters the bloodstream, sugar enters the bloodstream, pancreas detects increased level of blood glucose, the pancreas secretes insulin into the bloodstream, insulin increases the permeability of the cell's membranes to glucose, blood glucose level will begin to drop, the pancreas detects a drop in levels of blood glucose, the pancreas reduces its insulin secretion, and the cells become less permeable. On the other side of that, then the blood glucose level can drop. So glucose levels begin to drop. Pancreas detects a drop in blood glucose. The pancreas secretes glucagon into the bloodstream. Glucagon stimulates the release of glucose from the liver. Blood glucose levels begin to rise. Pancreas detects the rise in levels of blood glucose. The pancreas reduces its glucagon secretion, and the liver reduces its release of glucose. So glucagon and insulin, again, are working side by side to maintain that homeostasis. Any questions on any of that? I've gone through that really quick, guys, but I'm going to send this out to you, obviously, so you can look at it in a bit more detail yourself. If you do have any questions on these on a later date, as always, just give me a call or an email, and we can set something up to explain a little bit further. But any questions at the moment? Oh, I've missed one. Sorry. Sex hormones. Before you ask any questions, I'll just go through this one. So testosterone, produced in the testes of the male, 10 times more testosterone than females. Its functions include development of male sexual characteristics and growth and repair of tissue. So again, we think about testosterone as a performance-enhancing drug. That growth and repair of tissue, okay, is really, really beneficial to athletes. Estrogen is produced in the ovaries of the female, significantly higher levels in females than males, and the functions include development of female sexual characteristics and also sends fat deposition on buttocks and thighs. Okay, now have you guys got any questions? Sorry. Okay. Right, so we're going to look at some different types of clients that we may work with and how the neuroendocrine system will affect those types of clients. So a weight loss client, first of all. So exercise and nutrition, so our weight management equation. Can anybody tell me, for weight loss, within the weight management equation, what needs to happen? We're talking about energy in with energy out equaling weight loss. What needs to happen with our calories in, calories out? Which needs to be more or less?
Calories in need to be less than the output.
Yeah, exactly. So energy in needs to be less than energy out if we want weight loss. Okay, so think about the amount of calories that you're pulling in. If we want to lose weight, we need to make sure that the amount of calories in is less than the amount of calories out. So by creating an energy imbalance through exercise and nutrition, the nervous system will adapt accordingly. One example of this is insulin stimulation through the overconsumption of high GI foods. When insulin is released, it will reduce glucose levels in the blood, create a hunger feeling, and the natural reaction is to eat more high GI foods to suppress the hunger and give an energy boost. So high GI foods would be high in sugar, quick release of energy. Okay, so sugar comes in, quick energy boost, but then we get that energy crash, that sugar crash. Because of that sugar crash, what we tend to do then is go for more high GI foods to get the quick back up. So we're getting these insulin spikes and drops. Changing to a more low GI food or a combination will reduce the insulin response and ensure the individual stays fuller for longer. Exercise will also play a major role in weight loss, and the nervous system will respond accordingly. So when we train cardiovascular and resistance training methods, so both CV and weight training, both cardiovascular and resistance training have shown significant benefits for weight loss and burning calories. As mentioned previously, targeting the correct training zones and stimulating the required energy systems will show significant progress for weight loss clients. So cardiovascular, working in the fat burning zone and HIIT training. So during HIIT, the muscles burn a significant amount of their sugar stores, which triggers a reaction causing them to rapidly refuel by sucking glucose from elsewhere in the body. This process requires insulin, and over time the body responds by becoming more sensitive to small amounts of insulin. If insulin levels are high, the body is unable to burn fat as efficiently, so by making the body more sensitive to smaller amounts of insulin, you are able to re-engage the fat burning machinery. So we kind of looked at this a little bit yesterday when we looked at HIIT training and how it responds to burning fat. For resistance training, so strength training and endurance training, so weight training is more effective than cardio at building muscle. However, muscle burns more calories at rest than some other tissues, including fat. Because of this, it is commonly said that building muscle is the key to increasing your resting metabolism, your BMR, basal metabolic rate. The nervous system response to CV and resistance training, you get an increased basal metabolic rate. Hormone response is regulated with improved diet and exercise. You get a positive mental attitude and motivation towards the goals that are set. Regular physical exercise is shown to lower activity of the sympathetic nervous system and encourages activity of the parasympathetic nervous system instead. So the parasympathetic is going to push and work harder, and the sympathetic system is not going to take over as much. Okay, muscular strength, endurance, and sports performance clients. So we're going to kind of categorize both of these into the same bracket. So first of all, we're going to do a quick recap on the structure of a neuron. So structure of a neuron is as follows: cell body, the nucleus, dendrites at the end of the cell body. We've got the axon, which is surrounded by myelin sheath, and we've got the axon terminal. So this is where at the end of the nerve, so the peripheral nervous system sends out nerves. At the end of the nerves, we've got the neurons, which make up the nerve. So we've got all of these attached all the way along the nerve. And at the end, we've got the axon terminal, which attaches to our muscle fibers. So at the very bottom here, we've got the muscle fibers. Okay. So nervous transmission acts like so. So the message is sent down along the axon, okay, as it moves down along. As it moves down along, it is making a judgment call, and it is deciding how many muscle fibers need to be recruited. So the central nervous system sends the message, and as it moves down along, it is basically preparing for those amount of muscle fibers to activate. Acetylcholine, which are small sacs of neurotransmitter, they enable the transfer of an action potential from the end of a neuron to an adjoining cell. So we need acetylcholine to help that transfer of the action potential. Okay. So the action potential is the wave of electrical activity that passes along electrically excitable cells, passes down along each neuron. Acetylcholine, as we said, enables the transfer of an action potential from the end of a neuron to an adjoining cell. Is everybody with me so far? Or do you want me to go back over that?
Yeah, sorry, do you mind going through that again?
Yeah, it's quite heavy stuff. So yeah, no problem at all. Okay, let me just jump back up here. So what we've got, as you can see here, this is one neuron. Don't know if you can see, but on the nerve, which is on the right-hand side, we've got the long nerve. And then within the nerve, we've got tiny little yellow dot. Then we've got a longer blue line, tiny little yellow dot, longer blue line, little yellow dot, blue line. Can everybody see that? It's like the smallest section of the nerve. So what that is it's the cell body is the yellow bit, and then the axon is the blue bit. So you can see that neurons are basically branched all the way along the nerve, all the way through the body through the peripheral nervous system back to the central nervous system. So what we're doing is we're sending messages all the way along all of these millions and billions of neurons within the body. And as that message is traveled through each of those neurons, the action potential is the wave of electrical activity that passes along those cells. Okay. So as it's traveling along, the message is basically becoming clearer that, okay, we need to activate 50% of our muscle fibers. Okay. So by the time it gets to the muscle, it's ready to go with 50% to activate. So remember we spoke the other day about motor unit recruitment. Did we do that yesterday? Would be level 2 stuff, motor unit recruitment. I'm going to look at it again in a second anyway. So motor unit recruitment is basically deciding how many motor units need to be recruited to lift a certain weight. So that message is being sent down along the peripheral nervous system in millions and billions of neurons. And as it travels, it's basically making sure that by the time it gets to the muscle, the correct number of muscle fibers will be recruited. So action potential is traveling down along the axon. The action potential is the wave of electrical activity that passes along those cells. Acetylcholine is required to enable the transfer from the axon terminal down at the bottom, so where it says axon segment, okay, from that to the next cell body. Okay. So from the axon terminal, it needs to jump onto the next cell body as it travels down along the peripheral nervous system before it gets to those muscle fibers. I don't know if I've explained that correctly enough. Does that make sense, guys, or have I explained that right? So it's basically all about the transfer of information down along the nervous system from neuron to neuron to neuron to neuron before it gets to the muscle.
Yeah, that makes more sense. Thank you.
You sure? Okay. I can recap this again at a later date if you want to as well. So have a look over it again. Okay, so motor units. So this is kind of level 2 stuff. So a motor unit consists of a single motor neuron and the muscle fiber it innervates. So this is the end of that big line, the end of the nerves, right down at the muscle fibers. So a motor unit is a motor neuron and the muscle fiber that it connects to. When the nerve associated with a motor unit fires, the attached muscle fibers will activate 100%. Control of muscular force is determined by grading the number of motor units to be activated within the entire muscle. So control of muscular force is determined by grading the number of motor units. The message sent down, we need to activate this amount of muscle fibers to lift this weight. So when those muscle fibers are told to activate, they will activate 100%. Okay. All the rest stay dormant. So we're kind of recapping some level 2 stuff here. Does everybody understand about motor unit recruitment? We spoke a little bit about it yesterday when we looked at muscular strength training.
Could we go through it quickly?
Yeah. So give you an example. So some examples that we looked at on when we look at motor unit recruitment. So I've got my pen. So the pen is on the table. So message is sent from central nervous system down peripheral nervous system saying that, okay, the pen is really light. We only need to recruit 2% of muscle fibers in the muscles that are required to lift the pen. So those 2% of muscle fibers will activate and contract 100%. The other 98% will stay dormant, okay, to lift the pen up. I've got something a bit heavier, so I've got my phone. So phone's slightly heavier. Central nervous system says that's a bit heavier than the pen. So let's recruit 5% of muscle fibers to lift up the phone. So those 5% will contract fully. The other 95% will stay dormant. Then if we've got a box on the floor with a 50-kilogram plate in it, so central nervous system says, right, that's considerably heavier. Let's recruit 90% of muscle fibers to lift that weight. So those 90% will contract 100%. The other 10% won't do anything. So it's all about the central nervous system being able to assess and recruit the required number of motor units and muscle fibers to do the job at hand. So when we look at strength training, which we looked at yesterday, it's not about the muscles being strong, but it's about the nervous system being able to recruit the amount of motor units and muscle fibers to do the job in hand. The more you do it, the more the nervous system will be able to recruit more muscles. Now, you get to a certain point where you're going to need bigger muscle and bigger muscle fibers to be able to lift heavier and heavier weights. So that's where hypertrophy training comes in with strength. Okay, so example for you, or question for you, sorry. So I've got a box on the floor. So somebody has asked me to move the box, which contains a 50-kilogram plate. However, unbeknownst to me, somebody has taken the plate out and moved it already. So what happens when I go to lift the box? So I think there's a 50-kilogram plate in it. However, it's empty. What happens when I pick it up?
You lift it so easily that you nearly fall over.
Exactly, yeah. So you chuck it up in the air nearly because you have recruited too many muscle fibers, too many motor units to do the job in hand. Okay, if we flip it the other way, so I think the box is empty, actually a 50-kilogram plate in it. What happens then when I go to lift it?
You haven't recruited enough
probably,
muscle, so
yeah.
it doesn't go anywhere.
Yeah, so nothing happens because I haven't recruited enough. Exactly that. Okay, but because the messages send back and forward so quickly, so as soon as I put my hands on it and go to lift it, the peripheral nervous system sends messages back going, send back up. We haven't got enough here. So recruitment, more down. And this is where injuries can occur, is because it then starts to get different muscles involved and different movement to try and lift the weights that we're not actually prepared to lift. So what we should do is go, oh, that's heavier than I thought. Take a step back, allow the nervous system to process, and then go back in and use our manual handling technique to lift the weight properly. Okay. Another example that I've used on this as well is if you've ever walked up the stairs in the dark, and then you think there's one more step, but there isn't, what happens to your foot?
It slams down.
Yeah, so it slams down to the floor because you think you need to push your body weight up one more step. However, all you need to do is walk straight ahead. So your foot slams to the floor because you've recruited too many muscle fibers for the job at hand. Okay, so this is what we're talking about when it comes to motor unit recruitment. Recruiting the required amount of muscle fibers to do the job at hand. Does that make more sense?
Thank you for going through that.
No problem, that's fine. Cool. If anybody wants to pick this up at a later date, no problem at all, we can have a chat again. Okay, so I'm going to confuse you even further now. Muscle spindle stretch reflex. So what we're doing here is we are stretching a muscle. Actually, let me just go back and do that again. So we're going to stretch a muscle. So in this picture here, we can see quadriceps, the green arrows are showing that quadriceps is lengthening and stretching. Also, the gluteus maximus is lengthening and stretching. So what happens here is if we overstretch, so we're stretching the muscle too far, the muscle spindle, which is at the end of the motor unit, the muscle spindle will detect the rate of stretch. It will sense how far it's stretching. So if we're overstretching, the muscle spindle is sending a message back to the central nervous system saying, we're stretching too far here. It will then stimulate a muscular contraction. So it will automatically shorten the muscle to prevent injury. So muscle spindle stretch reflex states that elongation of a muscle stimulates contraction in the same muscle. Okay? So elongation of a muscle stimulates contraction in the same muscle. So what we're doing here is we're preventing injury. So think about if you are sitting on the floor, legs straight out in front, and you're stretching your hamstring. Okay, so you're trying to keep your leg as straight as possible. You're trying to lock your knee down and stretch your hamstring. When you overstretch, what happens to your knee?
It lifts up.
Say that again, sorry.
It starts to lift up.
Yeah, so the knee will start to bend. So what's happening here is the hamstring is contracting. So we're overstretching the hamstring. So the message is being sent back saying, we're stretching too far here. Contract the hamstring. So by contracting the hamstring, you get knee flexion and the knee bends. Okay, so we're preventing injury and preventing an overstretch. So it's like a stimulation. So it is a stimulation of the muscle spindle, basically saying we're going too far. You might notice as well if you're stretching that your leg shakes, which is basically it trying to bend, but you're kind of overriding the system a bit by forcing it to stay straight, so it'll shake. Have you ever noticed that?
Yeah.
Yeah. So different types of stretches. So if you overstretch, the muscle spindle will detect that you are stretching too far. It will send a message to the central nervous system. This is too much. The central nervous system will then send a message out saying, shorten that muscle, contract the muscle to prevent damage. Okay. On the opposite end of that, we've got the Golgi tendon organ inverse stretch reflex. So this is where we've got a muscle under tension. So the muscle is shortened. Okay. So we're holding a weight in our hand with the muscle shortened. Bicep curl, the bicep is contracted. Now we're holding it here for a long time. So the Golgi tendon organ senses that we've got lots and lots of pressure on this muscle. The Golgi tendon organ is activated. That sends a message out to the central nervous system saying, we're putting this muscle under too much pressure. So what the central nervous system then says is that that muscle needs to relax. So we get failure in the muscle. Okay, so it inhibits the muscle, causing it to relax. So Golgi tendon organ inverse stretch reflex, tension within the muscle inhibits the contraction in the same muscle. So it causes it to relax. So we're getting failure, if you like. So you think about if you're holding a plank position, and then you get to a point where just not happening anymore, and you end up dropping out of the plank. So what's happening here, the Golgi tendon organ is basically saying we're putting these muscles under too much pressure. So sends a message up to the central nervous system, and the central nervous system says, relax that muscle, lengthen that muscle to prevent damage. Now with both of these, we can override the system, okay, especially this one, okay? So we can really try and work through that pain barrier and override the system to work more. But this is where some injuries can occur. And I'll give you a really good example. I was out for a run a week and a half ago, and I felt a little twinge in my calf muscle, but instead of stopping, kept going and ended up pulling my calf. So this is what was happening. The Golgi tendon organ was basically saying, calf muscle can't cope with what's going on here. You need to stop. Okay? You need to relax that muscle. And it tried to relax the muscle, but I just kept going and then ended up damaging the muscle. So this is where you need to kind of listen to your body, which I didn't, but listen to your body to notice that this is what's happening. Does that make sense?
Yeah, brilliant.
Yeah.
Thank you.
It is really interesting. And we can see about how the central nervous system and the nervous system plays a big role in switching muscles on and off. Okay, so keeping that in mind, now what we're looking at is reciprocal inhibition. So muscle spindles and Golgi tendon organs help with the normal function and switching of muscles on and off. The agonist muscle stimulation creates an inhibitory impulse that reduces antagonist muscle activity. This is known as reciprocal inhibition. Now, what that means is the agonist muscle stimulation, so let's think bicep, stimulates, okay, creates an inhibitory impulse that reduces antagonist muscle activity. So by activating the agonist muscle, bicep, it sends a message and tells the antagonist to relax. So it's telling the bicep to relax to allow function of the bicep. And this is known as reciprocal inhibition. Does that make sense? Reciprocal inhibition plays an important role in the performance of exercise and daily activities. So switching muscles on and off, especially when it comes to stretching and PNF stretching. So PNF stretching requires a partner, so it is not always practical. It's best done by conditioned athletes and experienced instructors, as it requires a trusting relationship. And there's two types of PNF stretch. So you've got the PNF, contract, relax. So PNF, CR, contract, relax. PNF, CRAC, contract, relax, agonist, contract. Okay, so first of all, we've got the PNF, contract, relax. So the muscle being stretched is first contracted and held for 10 to 20 seconds. This will cause the Golgi tendon organ to register the tension and cause autogenic inhibition, allowing an increased range of movement when the muscle is stretched. Okay, so if we think back to our Golgi tendon organ inverse stretch reflex, muscle under tension. So if we tense that muscle, the Golgi tendon organ will send a message telling that muscle to relax further. So if I'm stretching somebody's hamstring, so I've got knee in this hand, foot in this hand, I'm stretching their hamstring. So we get that stretch, but then I tell them to cause tension in the hamstring. So ask them to bend their knee, okay, to a certain amount. So we're looking to just bend with a little bit of tension in the hamstring, bend in the knee. I stop it from bending, only hold it for about 10 to 20 seconds, then ask them to relax. So what's happening now is the Golgi tendon organ has sensed that tension and told the hamstring to relax further, so I can get a greater range of movement on it. So if you've ever done PNF stretching or had PNF stretching done on you, you'll notice that the range of movement that you can get is a lot further than what you would normally do on your own. Okay, does everybody understand what I'm saying with that?
Yeah.
Cool. So we cause tension, Golgi tendon organ switches the muscle off, allowing me to stretch it further. Contract, relax, agonist, contract. So this uses the previous method, but goes further by using reciprocal inhibition. So when the opposite muscle to the one being contracted has to relax. So the muscle being stretched is first contracted and held for 20 seconds, as we've just done. Then we relax the muscle, a brief pause, and the opposing muscle is contracted to pull further into the stretched position. So we've done our hamstring stretch, bend, cause tension in the muscle, relax it, stretch it. Now I'll tell my client to contract their quadriceps, try to lock their knee out as much as they can. And because reciprocal inhibition says that by contracting the quadriceps, it will send a message telling the hamstrings to relax. So it gives me an even deeper stretch. Does everybody understand that?
Is this similar to yoga? When you do stretches in yoga?
Yeah.
When people, you do a stretch and then they say, right, come off it again, and then do it again, so you get a deeper stretch. But then they sometimes use bands or things that you control to help get a deeper stretch, so you haven't got another person helping you, but you're doing it yourself.
Yeah.
Is that the theory?
It is. Yeah. You're exactly right. So it would be more about this one rather than this one. But when you're doing that now yourself, think about if I'm stretching my hamstring. And this is going to sound bad because so what you're going to say, I'm going to say to you to lock your knee when you stretch your hamstring and pull it, especially if you're lying on the floor. Because by locking your knee, you're contracting your quadriceps, which will then send a message to the hamstrings to relax, and you can get a deeper muscle. And then with the band, you can pull it further. So with the band, it is a little bit difficult to do it with the band because if you're trying to bend your knee and create tension in the hamstring, first of all, sometimes it doesn't work as well. Doing it against a wall, you can put your leg up against the wall and then push against the wall rather than a band and then stretch it further. So different things like that. But yeah, yoga, which is something I've been doing a little bit more recently, definitely does incorporate this sort of stuff.
Okay.
Cool. Okay, I'm going to move away from that and we're going to look a little bit at motor skills. So training motor skills can be more important for progressions in physical activities and sports, as well as general health and functional fitness. So training your motor skills will help with kinesthetic awareness, links between the central and nervous systems, helping with the everyday activities, improve sport and performance, and will reduce the risk of injuries. So can anybody tell me what the 6 components of skill-related fitness or motor fitness are?
Coordination,
Yep, that's 1.
speed, agility,
2, 3,
balance,
4,
reaction time.
5, 1 more.
Don't know.
Begins with P.
Perception. No.
Power.
Oh,
Close.
power.
No worries. Right. Good stuff. Okay, so our 6 components of skill-related motor fitness are speed, power, reaction time, coordination, balance, and agility. Okay, so speed, about quickness of movement; power, the ability to exert maximum muscular contraction instantly in an explosive burst of movements; reaction time, the ability to respond quickly to a stimulus; coordination, the ability to move 2 or more body parts under control smoothly and efficiently; balance, the ability to control the body's position, either stationary, for example, as a handstand, or while moving, so a gymnastics move; and agility, the ability to perform a series of explosive power movements in rapid succession in directions, such as zigzag running or cutting movements. So, principles of motor fitness training, so skill development and the learning process. Individuals need both time and practice to develop new specific skills. Managing your body weight, maneuvering your center of gravity, coordinating body movements, moving at different speeds in different directions and at different intensities will in the long term help to improve your motor skills. Think about yesterday when we spoke about multiplanar movements. So by doing multiplanar exercises, different directions, so sagittal plane, frontal plane, transverse plane, this is what we're talking about here. Managing your body weight, maneuvering your center of gravity, coordinating body movements, moving at different speeds in different directions and at different intensities will help to improve your motor skills. And there's 3 main stages of learning when training motor skills. So first of all is the cognitive stage. So this is where you've got a brand new exercise, you've never done it before. So it's all about learning the exercise. So I'm going to talk about step up. So step up onto a bench, stabilization. So you're going to hold it on one leg and you're going to do a bicep curl and shoulder press. Step up, hold it on one leg, bicep curl, shoulder press. Have any of you ever done that exercise before?
Yeah.
Step up to stabilization, curl and press. Okay. So if you haven't, the first time you do it is probably going to be without weights, no dumbbells. It's all about learning the movement, doing it with correct technique. So when you step up, it's about using the driving leg to power you up onto the bench. It's about switching on the core stability muscles to maintain your balance on one leg. And then again, maintain your balance while you perform a bicep curl and a shoulder press. So it's all about learning. Messages being sent back and forward from the central to peripheral nervous system and vice versa, basically saying switch this muscle on, switch this muscle on, switch this one off, etc., etc. Let's get the technique. So then what we do is we practice and practice and practice that. And we will then get to the motor stage where it's associative. You can perform the exercise. You don't have to think about it as much. So the central nervous system is basically saying, okay, we're doing this again. I remember from before we needed to switch these guys on. So let's switch all these muscles on. These muscle fibers need to engage. This amount of motor units need to recruit this amount of muscle fibers for us to perform this exercise. We're still thinking about it a bit, but we can perform it more effectively. Then we get to the automatic stage, autonomous, where We're coming up to do this exercise again. Central nervous system says, I know what I'm doing here, and switches everything on straight away. You don't even have to think about it. You step up, hold your balance, curl and press, step back down again, no issues. So the learning process starts at cognitive, where you're possibly falling off the bench, balance is going all the time, your arms are going everywhere when you're doing your curl and press. Motor is where you're performing with the technique correctly, but you still really have to think about everything to hold your balance and to perform it, and doing it slowly. Automatic is where you're just basically stepping up, holding your balance, bicep curl, shoulder press, perfect technique, no problem at all. So for us as personal trainers, we need to look at this with our clients. So if it's day one, it's all cognitive. It's all about learning it. We get them to the motor stage, and then we get them to the automatic stage over a number of weeks. Once we get to the automatic stage, what do we have to do? Or what will happen? So they've progressed to the automatic stage. What tends to happen now?
Will they plateau?
Yeah, so they'll plateau because everything is too easy. They know exactly what they're doing. They know exactly how to do it, and the body is performing it really efficiently. So what we'll maybe now do is we'll stick some dumbbells in their hands. Okay, so 4 kilogram dumbbells into your hands. Now we're going to perform it. So what we're doing now is we're bringing them back to the motor stage. So they can perform the exercise correctly. It's not back to cognitive because they know the movement, but because we've added extra weight in, the nervous system is going, hold on a second, these weren't here before. We need to now switch on more motor units, more muscle fibers to perform this exercise correctly. So we'll now do it with 4 kilogram dumbbells in hand. Practice, practice, practice. We'll get to a point where that becomes automatic. So then we'll start to plateau again. So then we'll chuck heavier dumbbells in, or we'll maybe do it with, we'll get them with a medicine ball, and we'll maybe step them up. When they step up and hold their balance, we'll add a twist in instead of the curl and press. So we're constantly changing the goalposts, moving the goalposts. So when they get to automatic, we bring them back to motor and then progress them up again. So it's all about bringing them back down to motor stage, progress, progress. Because if you do the same thing all the time, they'll just stay at automatic and they won't progress further. Okay? So it's not all about adding weights. We think about how we can progress exercises, change the exercises to make them more intense for our client and to challenge that nervous system a little bit more. Any questions on that? So think about your own exercises that you do, your own workouts. And for some of the exercises, think, right, am I at the motor stage still, or am I at the automatic stage? Do I need to challenge myself a little bit more? Okay. If you do the same running route all the time, it's automatic. Even before you set out, your central nervous system is basically saying, we're doing this one again. Switch on, off we go, easy. Whereas if you change your route constantly, your nervous system is guessing what's going on and has to adapt accordingly. Okay. Final slide. So neuromuscular adaptation. So the cardiovascular training causes adaptations in the neuromuscular system in relation to type 1 muscle fibers. So these changes include increased size and number of mitochondria, increased oxygen delivery to muscle fibers, increased aerobic enzyme in the muscular tissue, a greater supply of glycogen and triglycerides for energy, and improved tissue tolerance and resistance to fatigue. So the nervous system is basically causing all of this to happen. Because we're challenging the type 1 muscle fibers, it needs to supply to all of this to those muscle fibers. Resistance training and weighted workouts predominantly cause adaptations in the neuromuscular system in relation to type 2 muscle fibers. These changes include increased thickness and diameter of recruited muscle fibers, increased force production capacity of the muscle fibers, decreased nervous inhibition, so the messages being sent back and forward are more efficient, so there's no inhibitory response there. Increased tissue tolerance, excuse me, and resistance to fatigue under high stress or anaerobic conditions. So you're able to go longer and harder. Any questions?
No.
Okay, guys, if there's no questions, I shall leave it there.
Okay, thanks very much.
I just get my screen back up, guys. Sorry, just bear with me. I'm trying to stop this recording and everything's frozen. Bear with me, bear with me.